Good day, students. We're getting started today on our underwater fireworks. This is a very unique reaction where we have three different reactions. I've got two here and then one we're going to look at on the screen there in just a moment. We've seen one of these with a student that did a previous one when we did fire on ice. That was with the calcium carbide here, which is in this container, plus water. The water in this one is distilled water, and I've got it in a 1,000 milliliter graduated cylinder. Got an apparatus set up over here we'll look at in just a little bit. It's the same reaction that we had before. In this particular one, we have this, let's make sure I've got it balanced. Looks like we do. Yep, it's balanced. So we've got a word equation. We didn't use the term acetylene this time. We used ethyne to tie into a little bit of the stock system that we were studying. We have a separate reaction, and the unique thing about this is it's very random. The bubbles, as they come together, will ignite, and this is pretty unique. Because this occurs at room temperature. We don't have to create any extra heat for it. At room temperature is enough for it to occur. The bleach in the reaction is sodium hypochlorite, which we learned in our study of radicals. It says the hypochlorite radical is sodium hypochlorite, and it is aqueous. It's in about a 6% solution. We have hydrochloric acid, which in our study of binary acids we know has the prefix hydro on it. Of course, also in our study we learned that chlorine is diatomic and it never occurs by itself. It's either bonded with itself or something else. Then of course water can be written both as H2O and as HOH. It's just a matter of preference. And then of course the other product in this reaction is sodium chloride. Now if we look over here at the screen for just a moment, we can see I got this, I pulled this up, you can check it out. It's from Flynn Scientific. I give them credit for that. I thought it was very unique. You see the same two reactions I've got on the board, they just listed them a little bit differently. The thing I wanted you to see is that a progression that occurs almost instantaneously. We've got a triple bond between the two carbons here in the acetylene, and because chlorine has a higher electron affinity, which we studied about, than hydrogen, it pulls, it removes that hydrogen and gains that electron from carbon. It does it first in this reaction, in which we have an ene form, which means a double bond here, and you can see that in the reading. Then it continues with that reaction to remove the other bond, and then we get it's like an ane suffix because it only has a single bond. Remember, triple bonds have a yne suffix, double bonds have an ene suffix, and single bonds have an ane suffix. Anyway, this is your final reaction. You're going to see the product produced. We're going to generate some more hydrochloric acid. There'll be some little soot-like particles, which is the carbon reaction there. All right, let's take it back over here. Start putting this together so you can actually see the reaction. When we look at any reaction, there are some underlying factors that we don't have control over. We don't have control over, kind of like when we meet people on the street, what kind of reaction or conditions their background is. Well, like in our current situation, we're going to have random bubbles coming together, and if they collide, there will be an explosion underneath. Now I'm going to add the bleach first to the flask. Now I've created this device. It's just a piece of tubing that I've bent, and as you can see, it comes down, makes a little hook near the base of the graduated cylinder. And this, of course, is 1 liter. Okay, so I'm going to add the bleach first. Approximately 100 milliliters. And if you check on your containers, this is about 6%. Now I'm not going to add the acid next. Well, I am, but I'm going to go ahead and get my pebbles of calcium carbide ready. Don't need a huge piece, but one nice size would be good. I think that would be more than adequate. I don't want this to be something to inhale, because just the dust from that reacts in your lungs to make the ethyne, and so we don't want that to occur. All right, so I'm gonna get the lights, then I will pour out of this container, which is this little 50 milliliter graduated cylinder, which has the hydrochloric acid that I got out of this container. When it does that, it will start generating the chlorine gas here, and that will come into here. Then I will drop this pebble in that, and need to get me an igniter. Well, I think it should ignite itself. That's what we're predicting. All right, so we're going to get the lights. I'll turn off the computer, so we'll have it darkened in here. Got a lot of gas going on here, so. Let's see if I got any gas. There we go, we got a flash. There we go, got impatient. See the lights, see the flash. See a little bit of the soot occurring in the areas that explodes. There's even some at the top, you can see it occurring there with the two reactions. I have to keep shaking it to get the more chlorine gas. Occasionally we have an explosion at the surface. So therefore, the reason the vent is on is because some of the gas that escapes is, of course, chlorine, and that is harmful to our lungs as well. So, I think this was successful. We did have underwater fireworks. You were able to see all the predictions that took place. Turn that off for just a second so you can hear a little better. You can see the reaction. This is very unique in that we had 3 separate reactions occurring at the same time. This will continue for a while. So this will complete our demonstration of underwater fireworks. Hope you enjoyed it. Thank you.